Hello, everyone. Welcome back. Let's talk about OOP some more. Let's share some big realizations from that first session. What were some of the things that you were maybe a little fuzzy on at the beginning, and you were a little bit clearer on as we went on?
The big one for me was the whole input output thing and getting a good mental map down of how it is. Maybe we don't call it a function here, but we all know what it is.
Yes. Method is just a function that's on an object.
Right.
Cool. What else?
For me, it's using a method within the method. So, like when we did the is triangle thing, within is equilateral.
Totally. Yeah, we've got kind of those two tiers of methods too. We've got stuff that's just like our internal utilities. Those are our private methods. And then we have things that are how other people use our objects. That's part of our public methods. Cool. What else? Other takeaways from the first session?
It feels far more intuitive to me than basic JavaScript. Like the last function, you could just put is not isosceles, and you're good there.
Yeah.
I mean, the refactoring part of it seems simpler to make it like it just feels better to me.
Definitely. It's definitely more I've sometimes described the difference between object-oriented and functional programming as mathematical programming versus literary programming. Whereas like with functional programming, we're mostly concerned about correctness. Your code ends up kind of looking like math proofs versus the object-oriented stuff, which is nouns that verb each other. And so the metaphors like one-for-one translate a little bit better than they do with functional programming. Both of them have a place, but I find that most people tend to gravitate to or find one more intuitive than the other. Cool. More takeaways from this morning.
Did anybody say getter functions yet? Because
Hey!
I did not know they were a thing.
Mind blowing. Yeah, a function that we can treat like a property. Pretty cool. And like that's an example of like we've done some stuff where you like directly access properties and stuff on the object. You're not really supposed to do that. You're supposed to like have all of your properties just be part of like your state, and you encapsulate it, and then you use those getter methods to be your like abstraction away from that. So there's some disconnection between them, so we get some flexibility about how we calculate that stuff. In practice, though, in JavaScript, most people just mutate the properties directly. But in pure OOP theory, you're not supposed to. What else?
It's easier to keep something working than to get something working. I thought that was a really big takeaway.
Yeah.
Just because we're so focused on problem solving, you know what I mean, and getting it working, that if you do get to that point, and then you can start look to see like what you have, then you can start refactoring and start making better decisions. So
yes.
That was my takeaway.
Yeah, get it. Like your first solution to something should be dirty and gross. Just get it there. Get it green. Get it working. But then this is the thing that, like, level one is trying to like think too hard about crafting the perfect solution first. Level two is getting it working kind of dirty and then just moving on because you're so excited that you turned something green and you don't want to mess it up. Level three is get it working dirty and then stop and make it good before you move on. That's how you don't hate your life as a programmer. Cool. Give me one more takeaway from this morning.
It just a tail end with that with the testing. Just same thing when we switched over to equilateral. Oh no, so when we switched to isosceles and we went into the testing, I had mentioned to you that there was multiple tests we needed to do. I was like, I want to see one turn green, so I'm just gonna put one of them in. I know it's not all the answers, but I'm gonna put that one in, run the test, and go, okay, yes, okay, I see some turning green now, and then which ones failed. Okay, move on with the additional tests. It really helped by doing it that way.
Absolutely, baby steps. Cool. Well, let's do another one. Let's do that robot name one. It's a pretty good one. And that one uses static stuff too. So if you are here, I'll throw the link in chat. Why don't you go ahead and pull that one down if you'd be so kind. I'm going to do the same.
Hey, Kyle, you're not sharing. Just FYI.
I'm not intending to just yet.
Okay.
I'm getting my directories going. All right, here we go. Good looking out, though. All right, so first thing that you need to do once you've pulled this down is npm install. All right, once you finish downloading half the internet, go ahead and run those tests. npm test -- space -- watch all. And off they goes. 10 failing tests. You'll love to see it. All right, I know that it is taking a while to get dependencies installed on y'all's computers. Take a second to get caught up.
Did you say -- space -- watch all?
Yeah. So the reason why, oops, took it away already. The command looks like that. npm test -- space -- watch all. If I do npx jest, it's just -- watch all. But that extra -- in there is how I pass that flag to my test command. Because remember, my actual npm test, that's jest. If I want to pass additional things to that, I need that extra -- in there. Like that. That gets the -- watch all over to jest. Otherwise, it thinks I'm just trying to pass a flag to the npm command. All right, checking in. Give me a thumbs up if you're ready to rock. All right, I see 3 of them, 4 of them, 5 of them, 6 of them, 7, 8, 9, 10, 11, 12, 13. All right, I'm going to call that quorum.
Real quick before we move on, I'm sorry.
Totally.
When I did that watch all, npm test -- watch all, it's given me it said like press enter to run more. So I did enter, and now it's asking watch usage, press W to show more.
Like this? All this stuff?
Yeah.
Watch usage? Yeah, that's fine.
Okay.
So what this will do is it'll automatically rerun anytime we change our code. So you don't need to keep manually rerunning it.
Oh, fantastic. Okay.
Yeah, man. All right, so requirements for this. When a robot comes off the factory floor, it has no name. The first time you turn on a robot, a random name is generated in the format of 2 uppercase letters followed by 3 digits. Every once in a while, we need to reset a robot to its factory settings, which means that the robot's name gets wiped. The next time you ask, it'll have a new random name. The names must be random. They should not follow a predictable sequence. Using random names means a risk of collisions. Your solution must ensure that every existing robot has a unique name. For the submissions I've seen on this so far, that's the collisions is what people are having the hardest time with, because it's the hardest part of the problem. So first I want to talk briefly about what a collision is. So if I generate a random number between 1 and 10, I might end up with 2, and then 6, and then 8, and then, 6. So a collision is when you need those things to be unique, and they're not. So a practical example of where these tend to happen. I'll get my camera right. Practical example of where these tend to happen is in like universal IDs. So I'll show you an example. So UUIDs are universally unique IDs. And that means that every one of these is expected to be unique. So if I refresh, I get a different one, and a different one, and a different one. And if I did this from now to the end of time, I should statistically get a completely different one every single time. If they cannot, if it is super important that they don't collide or accidentally generate the same one twice, it needs to keep track of the ones that it's already generated so it can compare it to that. If it accidentally generates that, it knows to do another one. So what that looks like over here would be we get a 2, and then over here we keep track of that. And we get a 6, and an 8. And then when we generate a 6 again, we look up that we've already generated that. And so then we generate another one instead. And then when you generate an 8 again, it goes, oh, already have an 8. And it goes, cool, how about a 6? Sorry, already have a 6. All right, how about a 5? So we need something that keeps track of the ones that we've already generated. That's like the hard part of that problem. Cool. So just like last time, let's start by just narrowing down the tests. So do I have describes on this? No. All right, 1. So it's saying robot should have a name. Okay. It's name RE. We'll take a look at the test. So what it's doing is it declares a robot here. Before every one of these tests, it makes a new robot and assigns it over here. And afterward, it calls release names. So one of the first things that it's probably mad about is that it tried to run this test and it didn't have a release names thing that it could call. And then the actual test is looking for a name property, and it's expecting it to match this name regex. We haven't talked a ton about regexes, but that's what they look like. They're patterns. There's no chance that you like get good at writing regexes by the end of this program, but what this says is it has a capital letter A through Z. There are 2 of them followed by 3 digits. That $sign means that's the end of the string. The caret means it's the beginning of the string. So that means that the entirety of the string is 2 capital letters followed by 3 numbers. And so it's expecting that whatever random robot got generated has a name in that format. So to get that test going green, we can do 2 things. One, we can just hard code something in that format, and then we need to give it a release names method. And does that take anything? It does not. Return null. All right. Release names. That's weird.
I noticed this too. I think it should be small r. Or is
it
for
is,
robot?
Oh, I see. No, it's because it's capital R. Who can tell me what that means? That's kind of like why I picked this one.
The class.
It's a class, right?
Like capital R robot is the class, not my lowercase r robot. That's my object. That's my instance. So what is it called if there's a method that's on the class itself?
An instance of?
No? Good guess.
Got it.
Static. Release names is a static method. So if I make that static release names, all of a sudden it's not mad. That means it's owned by the actual class itself, not any particular instance made by the class. And this is where the cookie cutter and blueprint metaphors start falling apart. Is because like the cookie cutter itself like tends to not really have anything special about it. But classes can also have properties and methods, and they tend to relate to things that involve more than one object. So for example, if I want to be able to find out what's the largest triangle that you've ever made, well, every individual triangle wouldn't have enough information. It doesn't know how to compare itself to other triangles. The triangle class itself could be keeping track of all the triangles that get instantiated. And that could have a method that compares all of those and gives you the one with the biggest area or whatever. That would be a static method of the class rather than an instance method of one of the objects. So the way that we're going to solve this problem is keeping track of all the names that we make on the class, not on any particular robot that we make with that class. So it would make sense, too, that this release names would be a static method because we need to clear out all of the names that we've already used. We're going to keep track of those on the class, not on an instance. Questions about that idea?
So we have a way of doing it by you're making it static on the class, but what does it do? How does it store it? Like, where is it putting it? Is it putting it into an array or?
Totally. So you would also have a property on here that's like static used names or something. And maybe that's an array. And then every time we generate a new name, we add it to that array.
So with our class already being called capital robot, how does it not like know that what we're putting in there would be a static property?
Because if it's like name is not a static property. The class of robot doesn't have a name property. Any one robot that's made with this class, that has a name property. So what that would look like is some robot would be new robot, and that would have a name property. But it would not have a used names property. Versus the actual robot class itself wouldn't have a name property, but would have a used names property.
So if we were putting the constructor in, that wouldn't kind of allow for it? I guess that's where I'm confused. Is like, could you not like what instantiated or whatever the word is that I can't think now? It's that I'm talking. If you were to do that, it wouldn't take care of it by putting a constructor in?
No,
not at
so
all?
the constructor says make a cookie with the cookie cutter. Once the cookie's made, it doesn't remember that it came from the cookie cutter, really. It's not like it's on the cookie sheet. It's in your mouth. It's in your tummy. But like it's not part of the cookie cutter anymore.
It doesn't know it came from robot. Okay.
Exactly. These don't know anything about specific robots necessarily. But we can still put properties and methods on them. And we'll see how we can have these things kind of talk to each other. But yeah, a particular robot doesn't, it's not like it also gets the static properties and methods. So this one will have a release names method. Any one robot does not have a release names method. All right, let's see how our tests are doing. All right, I got a passing test. I got another passing test. I got a failing test because I hard-coded the name. So now I need to start working on what that robots having different names logic looks like. So since this is something that happens to the robot when you make a new one, that means it's part of the constructor. That's when it gets its name. Because every robot has to have a name. It's not valid for it to not have a name. That means that needs to get taken care of in there. So we could say that name is a string. And we could say that this dot name equals that. Now we should have like the same error that we had before. And we do. So now instead of hard coding this, we need to generate it. So probably the easiest way to do this is going to be to keep track of have like an array of all the letters and all the numbers, and then randomly pick one and try to build it that way. So we could do like const letters equals, and do they have one in the test? I'll bet they do. Do they? Nope. All right, so, or actually, I probably don't even need to use an array. I'll bet I can do this with a string. A, B, C, D, E, F. There we go. All right, cool. So then to build a name, I need to be able to get a random letter and get a random number. So the way that getting a random whatever works in every programming language is that you use the computer's PNG, or pseudo-random number generator. So there's your like big vocab word. So the reason they're called pseudo-random number generators is because they're not actually random. Computers don't know how to do random. It is like, in fact, the thing that they are the worst at in the whole world is doing something random. And so what they do instead is they have a formula for how they generate the number, but they have it based on other things that are presumably random. And like in practice, what that means is you have a thing called like a number table. So it'll just be like a grid of randomly distributed whatevers. And you'll do something like based on the time of day, like the exact timestamp. You'll go, okay, that means that the starting number is this, and then I build out the numbers going left because the direction that I go on this is determined by some other kind of random factor, like how hot the processor is or something like that. And so then when you ask it to generate a random number, it goes 764 or something. And so the reason that it's really important to make the distinction between pseudo-random and random numbers is that pseudo-random numbers can sometimes kind of be predicted. If you can figure out what the factors are that cause it to generate something, then you might be able to recreate them. So if you're doing some kind of randomization thing as part of, say, password management or some kind of security thing, you have to be careful about how cryptographically secure whatever system they're using to generate this stuff is. All right, end of rant on pseudo-random numbers. Okay, so the way that we use pseudo-random number generator in JavaScript is with math.random. So math.random generates a pseudo-random number. And it looks like this. Come on. Gives you a number between 0 and 1. That's all it does. That is the source of randomness in JavaScript. So to make this do what we want it to do, we need to sort of torture it a little bit. We could say I want to math.floor my math.random number. Oops. Well, I need to multiply it by something first. Like, oh, I don't know, 26. And so if I do that, I'm always going to get a number between 0 and 26. Just a little math trick. That's a number between 0 and 1. If I multiply it by 26, now it's between 0 and 26, but it has all those decimals. So math.floor rounds it down. Pretty cool.
Could you multiply by 10 and use that just to put for your numbers?
I absolutely could. So if I change that to random number between 1 and 10 or whatever, so it'll be 0 and 9 technically, but there you go.
I meant like instead of your const numbers equals 1 through 10, would you still need that?
Oh, I guess I wouldn't. So at this point, go ahead.
If we're creating a 3-digit number, why wouldn't we just do math.floor, times math.random times 999, and that would give us a 3-digit number, right?
We can totally do that. Works for me. The important thing is that all of that stuff is implementation details, so none of those should be public methods. We want to be able to go like, okay, I wrote it this way, and then a week later I came up with a smarter way to do it. The interface for robot never changes. So like if I make a function that's like get random number 0 to 9. So if I have something like that, I go, okay, cool. I call this 3 times. Oh no, psych, that's stupid. I could do that 0 to 999 and do the same thing instead of calling that 3 times. I've changed how I'm doing that, but robot still works the same way. You don't pass anything into the constructor and it has a name property that like has the same shape to it. That's part of abstraction. We don't care how this work gets done. We care about what is publicly available to consumers of the robot class. But yeah, let's say I have a private method called getRandomNumber 0 through 99. That could be return math.floor math.random times 1,000. Love it. So then I have another one that's like get random letter. And so that's going to be whatever through 26. I can move this letters thing into this method. Say that's a random number. And then I can return letters at random number. So now I have a teeny tiny little function that gets a random letter. I have a teeny tiny function that gets a random number. Not bloody bad. I can even make one that's like get 3 random letters that calls get random letter 3 times. So maybe that's this dot get random letter, then return letter 1, letter 2, letter 3. So then if I want to randomly generate a name, hey, that sounds like another private method. Somebody who's using the robot class doesn't necessarily need to have access to my generate random name thing. It gets automatically handled by the constructor, but this allows me to break up the logic into smaller and smaller pieces. So this is going to be like return get 3 random letters, get random number 0 to 999. And hey, since we know about getters now, Could I turn these into getters instead? Why, yes, I could. I'd say, just put a space there. Just put a space there. Just put a space there. And now I don't need to invoke these anymore. All right, why is it fustering? Oh, it's because it's not called get random letter anymore. Kind of cool. So now I have this like generate random name thing. I guess I could turn this into a getter too. I don't know that it actually helps to make it a getter. Maybe it reads better as a method, but regardless, say this.name equals this.random name. How did my tests like that? Oop, I got 3 random letters and I needed 2 random letters. Tests like that.
Can you pause for like 1 second?
I'm gonna pause for way more than that. Let's
Thank
chat about
God.
everything I just did. So let's walk backwards from what I was doing, which was trying to make sure that robots have different names. All right, that means I need to randomly generate them. So I go, okay, how do I randomly generate things? Well, all of it, anytime you're randomly generating anything, it's always based off of math.random or the equivalent to that in whatever language you're using. Every language has some way to generate random numbers, and that's what all randomness is in a program. We use things like this to get a random number between this and this. We use floor to make sure that it's an integer so we can use it for like array indexes and stuff. But yeah, if you want a random one of 10 different things, then that math.floor is how you're going to make sure that's the thing. Multiplying it by 10 tells it how many there should be. So we used that in 2 different places. We used that to generate something 0 to 999. By the way, if this was math.ceil, it would be 1 to 1,000. So we can call that one all day long and just get random numbers.
An issue I just ran into with that random number 0 to 999.
Yeah.
You're not always going to get a 3-digit number. You could get a single-digit number. You could get a double-digit number. And you might pass now, but about 10% of the time, it won't.
Wahahaha. So, yeah, maybe that's an argument to do it in 3. There's one other way we could do that, and we mentioned it way briefly like a couple weeks ago. It was a big scandal on NPM. How else could we do that with this one that we have here?
I don't remember a scandal, but we could use like a module, right? Like a not data.fm, but something, or what's the other one?
Is it the thing that broke the internet or whatever?
The thing that broke the internet.
Oh, the guy who just shut it all down, right?
Yep. That function, left pad. take something and then make sure that it's always 3 digits long. Pad it with zeros on the left if you need to. That's what left pad is. But you know what? Let's do it by just doing this 3 times. So we'll make that get a random number 0 to 9. And then we'll have like a get 3, get random 3 digits. And since those could be like 0, 0, 1 or something, and we don't want JavaScript to truncate those, they're digits, not numbers, because this should come back as a string. So what we can do is return random number 0 to 9, random number 0 to 9. And then this will be random 3 digits. All right, how are my tests feeling? Oop, didn't like something.
Do you need one more
yes.
random number 0 to 9?
Yes, I do. All right, tests are happy. Some important things to recognize in this. The only public code that I have right now is this constructor. I can call new robot. I can't call robot.randomName. I cannot call robot.toRandomLetters. I cannot do any of those things. And that's cool because if I find some neater way to do this, like for example, fuck that. I'm going to go back to generating 1 to 1,000 and then I'm going to use left pad. I can change this implementation and every single one of these tests will still pass. Because the tests, since they're using the code kind of like a normal person would, they also can't access any of these private methods. That's a good thing. That's how we keep from making our tests just a mirror of whatever our code is. And so every time our code changes, we also need to change our tests. That's a sign that you wrote bad tests.
Is your first test still passing as well? That the robot has a name?
Yep.
For some reason, that's the only one that's not passing all of a sudden.
Check your return values.
Okay.
So I think of private methods as, these are all just little utilities. All of them are tiny. There isn't one of these that's more than 3 lines long. They're all individually very easy to write, very easy to understand, and we can use them to make some pretty complicated behavior. So in our cells metaphor, within the cell, it's got all of these pieces that work together to allow this cell to do all kinds of different things. That doesn't mean something outside the cell can work with the mitochondria and the electrons and whatever else in there. It's still passing chemicals in and out of the membrane of the cell. So it goes with this. All of this stuff is, you could say, encapsulated away. Ask me some more questions about this.
So mine's still failing a few tests. If I could pull it up and show you guys.
Please.
Sweet. Let's see here, one moment. Rad. All right. So once we can see it all, nice. I'm pretty sure I was able to follow along if we see anything inherently wrong.
Yes.
Which
so you're using on line 14, using like this dot get two letters as if it were a property or a getter, but on 16 and 22, those aren't getters. Those are just regular methods.
I see here. Let me see.
So then you hold on, and then you want a lowercase. Get it back to camel case. Yeah, there you go.
There we go. Okay, let's try that again. And then you said back to camel case for our gets. And that's going to be standard for all gets.
Yep. The only things that are Pascal cased are classes and types. Everything else is camel cased.
Perfect. So why don't I just go ahead and get these in here? Puns intended.
Yeah.
Okay, that's looking a little prettier.
All right, but I can still tell that there's something funky because you're still getting that definite assignment issue on line 2.
Yes.
So that's probably a source of some of our woes. You've declared a name type. You are definitely assigning it on line 10, but check out line 9.
I'm seeing constructor.
Are you?
I sure think I am.
Construct, is that how you spell it?
And like, here's why that's not an error. A class doesn't need to have a constructor, and spelling constructor wrong is a legal method name, so that's not an error. That's why I didn't catch it.
And so the test that it's still failing has a name.
Okay, so it said it was expecting something to match this, and it got all that crap instead. So let's take a look at what you got. And your name is this dot random name. Random name is a method that returns this dot 2 letters and this dot random digits. This dot 2 letters is a method that returns that string. This dot random digits is a getter that returns this dot get random number 0 to 99, which is not a getter, and you're using
right.
one.
This is going to be our problem that we faced in the last one, so we can just quickly go through and fix these right up.
All right, now take a look at your test.
Thank you, guys. And
I see fields of green, red roses too. All right, very nice.
Excellent. Thank you.
Other questions thus far?
No, thank you for sharing. That's exactly the problem I had too. So appreciate it.
Someone has to be the guinea pig.
Can I also volunteer to be a guinea pig real quick?
Please do.
Thank you. Put this over here. Share. Okay. Can everyone see that okay?
Yes, sir.
All right. So here is my code.
Okay. Okay, so you've actually got the same issue on line 13. You're using get 2 random letters as if it were a getter. It is not a getter.
Okay. And get 2 random letters.
It's on line 16.
Yeah, there we go. Two random letters. A get accessor must return a value.
What's being returned from that method?
Nothing.
Yeah. See, all those errors are helping you. It's the only way that the computer can talk back to you and be like, you missed something, you missed something.
I see. And then real quick too, so this one's going to return Isn't this one just going to return this dot random letter then?
Well, you have two randomly generated letters there. So how would you return them together?
Return two random letters.
Nope. Because your actual two random letters are letter 1 and letter 2. So how do you return them together?
1 plus letter 2.
That'll do it. You can also put them in a template string. You can also concat them. Lots of different ways to combine two strings into one string. But there you go.
Okay. And I guess just real quick to double check. Cool. Thank you.
All right. Anything else so far? So walking through it one more time. When you generate a new robot, some robot equals new robot. New means call the constructor. The constructor sets the name property, which we know is a string. It's going to set the name property to whatever this dot random name is. This dot random name is a getter. It returns a string with two random letters and random 3 digits. So I already hate that. So let's fix that to 3 random digits. Much better. So it returns a string with 2 random letters and 3 random digits. Also, like, you see how this is starting to read like a story, kind of? That's a sign of good code. Okay, so 2 random letters and 3 random digits. Well, 2 random letters is a random letter and a random letter and bringing them together in a thing. Could have also done like Bryce did. Letter 1 plus letter 2 does the same thing. And then random letter takes a string of all the things, gets a random number between 0 and 25, and then returns that letter. Get 2 of those, and that's that. 3 random digits. Similar kind of thing, except it's random number 0 to 9. This is a method that generates a random number from 0 to 9. So, putting it all together, we would expect to have 2 random letters and 3 random digits. And that is kind of what the test shows up as. Feeling good about this? Anything else we want to touch base on?
This may be a dumb question, but when you say this random name, how does it know to call to actually, I guess it's all built into the get to pull it from that method?
Bingo.
Okay.
Like what a getter is even though this is a function, I can use it like I could a property because I told it it's a getter. That's like a shorthand for invoke this and then just evaluate that to whatever the returned value would be. And that's way more common in like object-oriented style, is to treat your methods that way. Because in pure object-oriented style, you're never supposed to be able to get the properties directly, only call public methods. So that means you'd never this dot some property name. It would always, the only thing you can do is make some robot and then do some robot dot some method. That's the only thing it's possible to do.
So if this was something that actually like a user could interface, you would have to have a button to start, like make robot, or actually it would just be where you create a new robot.
Exactly.
All right.
Like that's the only thing that somebody who's using this class can do right now. Is that there are no other public methods available other than some robot.name. But like, that's it. Those are the two things that this class can do that are part of the interface. But generating that name requires all this work. But there's like 50 different ways that we could have done all of this code. So we make it private so that if we change how we implement that, no code that generates robots needs to change at all. Other questions?
I have a question.
Yeah.
If robot had an interface, what would it look like since everything is private?
Beautiful. So we could say the interface for robot. You can make assertions about the constructor. So you could say that the constructor does not take anything and returns void. Well, let me do that.
Would you be able to put the name in the interface for the class of robot or no?
Yes, because it's public right now. So I could say name is string, and that's fine. That'll leave me alone.
Was it throwing that error because your constructor returns a string and you were trying to do the return void?
My constructor doesn't return anything. It does an assignment,
No? Oh, okay.
But nothing actually gets returned from it. Maybe constructors get typed differently. Let's see. TypeScript, interface, constructor. So again, pro tip on Stack Overflow, always skip the question. Either the answer answers your problem or it doesn't. So
Yeah, I found that a lot.
see, that sucks. Ooh. Maybe doing it with new. So can I say that new is void? Yeah, it thinks it's a property. Interface, type the constructor.
I think in that Stack Overflow, new didn't have a colon. It was new, and then you immediately open the parentheses. But
they're this two different syntaxes for the same thing.
Okay, gotcha.
Abstract classes. Oh, interesting. See, this is what I'm talking about with these like clever, shitty variable names. See how hard this makes it to read anything? Ugh. It makes me like angry to see code that looks like that. So much harder to read. All right. But I don't understand why it was why that return type. Oh, because yeah, I got it. It's because the return type isn't that. It's going to be whatever the actual thing is. Maybe just robot. I don't know. I might need to do some research on this. But like that's the gist of it. Is like since it doesn't really have anything public right now other than the name, then that's the only thing that we can put in the interface. Other questions so far? All right, onward. So let's see if this, how this handles like the next test. It is able to reset the name. It goes, hey, you don't have a function called reset name. So that's something that I would, since it's being called over here, that's part of the interface. So I could say that reset name is a function that maybe returns void. Does anything get returned from that? Nope. So since it doesn't return anything, we say that it returns void. And this is saying, hey, you're missing that thing. So I could say, cool, give me a reset name method that doesn't return anything. All right, so what this was expecting was that if you call the reset method on it, then it wouldn't have the same name that it had before. Okay? So that means that it needs to get a different random name. So it's really like the same as the constructor. Passing. Love it when something slick like that works. But yeah, this .random name already generates another name. So just use that. Onward. It should set a unique name after a reset. Ooh, this one might be interesting. Expected this many names. Only got that many. That means collisions. I'll bet if I run this again, I get a different number back. Yep. I get a different number every time because the difference between 10,001 and whatever I'm getting back, that's how many collisions occurred. Questions about that? So we're going to do something similar to what we're going to do on with those like static properties. And now let's use the static properties. This is a good time to do that. So here's the trick. We need to keep track of every time we generate a name so that we don't use it again. I think the easiest way to do that is instead of saving this directly in here, we do something like const new name equals this dot random name and this dot name equals new name. So that's the exact same code. We just split it up into two steps. But it gives us the opportunity to push the name that we generated into use names and or check whether or not it's already been there, or if it's already in that array. So I could do something like used name. Oh, so it's a static property, so I can't do this dot use names because it's part of the class. It's not part of my robot that I made. So here's the magic trick. Blink and you'll miss it. Capital R robot dot used names dot push. And so I need to tell it what kind of thing these are. So I'll just say string for now. Oh, why won't it let me do that? Oh, because those are incompatible types. That would make sense. So those are going to be an array of strings. Whenever I generate a new name, I'm going to push it in there and then set it. Now what I really want to do is check to see if that new name that I generated is already in there. And if it's not, then I want to try again. So, so we could do this with a loop. Maybe a while loop would be good for that. So something like while robot.used names includes new name. Ooh, actually, you know what this is? This is a case for do while. So this would be like do. It's not very often you get one of these. Let new name. There you go. So check this out. This is like procedural programming classic. Make a scope placeholder because this is inside of a block. So if I assign something in there, it doesn't exist anymore outside of that block. So I need to declare the variable there. Do this at least one time. And then if that used names includes the name that you just generated, do it again. And keep doing that until that's not true anymore. And then push it into the use names and then set it.
You don't need to open up another curly brace after the while statement.
So this is like the rarest kind of looping construct, but it works like this. So that's a normal while loop. A do while loop is just that backwards. And it starts with the word do. But no, there's like, that is the end of it. While is describing these braces that came before it. Do this so long as this is true versus do this until this is false. But if this condition is originally false, then this body never runs. This will always run at least one time. So does it check the condition first or does it check the condition last? That's the difference between those.
Gotcha.
And we want it
very,
to
very clever.
Isn't it? Like, we want it to generate a new name at least once. We just want it to keep doing it until it's found a unique one.
Did we check our tests now? Because when I tried to run, nothing's happening. I'm wondering if we may have created an infinite loop somewhere in there.
Probably. Oh, it's probably like
same here.
Opposite. We want it to be as long as that the use names doesn't include the new name. So yeah, probably infinite looped. Yep, that is an upset puppy. So easiest way to fix that just is a node process. So if you can get over to a shell, do kill all node, and now it's done. But that's like that's your Control-Alt-Delete. That's your safety valve for something like that. I'll try running it again.
I think this one might have been the last straw for my computer.
Oh,
mine reset VS Code too. Like it was like, sorry, you can't keep going. When I did the kill all.
I might still have an infinite loop somewhere in there.
Same, Julie.
No.
So what was it?
No, that.
What was the kill all again?
Kill all node like that.
Okay. I just hit Control C in my terminal on VS Code because that's where I was running the test, and it like looked like it stopped it.
Oh, that's fine
mine
too.
Looked like it stopped it, but it didn't.
So sometimes when you do that, if you can get it through, the problem is since it's infinitely looping, it doesn't give you any. It doesn't give the processor any time to listen for that Control C. So that's usually why you have to do it from another process. Okay. I think it's still happening, so let's walk through this, and you can go ahead and stop following along, so you don't have to keep doing this. I'll take the hit so you don't have to. Okay, so we initialize an empty new name. We set it to a new random value, so long as the robot's static used names array includes new name. Oh, we don't want that. We want it to be while it doesn't include the name. Yeah. We want it to keep doing that until it doesn't include that name. Because if it does include the name, we want it to do it again. No, that's right. I think that
Do you want it to check when it doesn't? Should we say run it while it includes not new name?
No, because that just coerces it to false. And so it's going to look for the Boolean false inside here.
Gotcha. Okay.
Okay, so whenever I get like kind of turned around like this, here's the process. We draw it out longhand. Come up with concrete examples. So an example would be used names is nothing. New name, actually, even better. Let's draw on top of it. So if use names is 0, or is an empty array, so that's nothing, and then we set it to some random name. So we say that new name is AA111. While robot.useName, so that's an empty array, includes that. So it does not include that, and so it keeps going.
Wait, does it need to push it in before running the loop again?
See, it needs to check. So like this is the check. So if new name is that, does robot.useNames, which is an empty array, does an empty array include the name that we just generated? No, it does not. So this is false. And since that's false, it stops looping. But this should still be AA111. So then we should be able to push that in and then set the name. It's my theory, at least.
So my question is, Kyle, everything that follows, so on your while line, you know, the robot.usenames.includes, the stuff that comes after it, where you push the new name in and then you set the name property to the new name variable.
Yeah.
Does that still occur in the do while loop?
No, all of that is separate. The only part that loops is this.
Right, and so that's what I think is the holdup, because if we create a new name and use the empty array of use name does not include it, which it won't because it's empty, it's just going to generate another name, right?
No.
And keep going and not append it.
Since that name isn't in the empty array, this whole expression evaluates to false. If that condition is false, it stops looping.
Gotcha.
I mean,
I follow now.
It's still not working, but that's the logic of this. If we evaluate this expression, it evaluates to false because there's nothing in there. Ergo, it shouldn't try to loop again. If it did find something in there, if AA111 was in there, hey, does this include the name that we just generated? Why, yes, it does. So this is true. That would make it loop a second time. I mean, check my logic. Does that follow?
That makes sense to me. I just had to have you explain it like again one more time. But yeah, it clicks.
All right. So it could be like one of the other tests or something that's driving it nuts. So what I would do now is let's give it a shot. Can I just create a robot without crashing my computer? So if I do new...
We're just going to let you try this one because the answer for all of us is no.
Well, and remember, I told you, don't follow along. So if I npm, or sorry, node, oh, I have to, shoot, npx ts node. Yeah, no kidding. It should have let me do that anyway. I have a TS config, do I not? All right, let's just try compiling it. Oh, I need to raise my target. Let's see. I did. That's a pretty... ESNext is as high as you can go. Man, I don't know why it's being fussy about that. All right, let me see if it'll... If I narrow it down to just this one test... will it let me run it? Hey, it didn't lock up on me. That's something. And so what it was doing in that test was makes 10,000 robots, keeps track of the names, adds the name of the robot that I made, calls reset name. Ah, there we go. Because I'm doing this in the constructor, but I'm not doing it here. So I can take that cool logic that I made, and that seems like another great thing to move into a method. So this could be like private get unique random name. And so if I move some of this logic over here, does all that kind of stuff. Does all that. And now instead of assigning this directly, I can return it. And then both of these become this dot unique random name. And same thing here. All right, how you like me now? Oops, something I didn't like. Accidentally generate that TS. I feel like that might be the problem. Hey, I see fields of green. So let's take a look at the logic on that. So both of these still work the same way, but we moved out that unique generation logic to something that generates a unique one. Keeps this placeholder, tries to generate a new name. It's guaranteed to do that at least once. If that's already in there, it tries to do it again and keeps trying to do it until it gets an actually unique one. Then it adds the name that we generated to the used names and then returns whatever the name it generated was. And so then we can assign it.
What did you change to actually stop the infinite loop?
So I have a hunch what was happening with the infinite loops is, every time you save, it reruns the test. If some intermediate state while you were writing this caused an infinite loop, it's not like that stops when you correct the code. So my guess is that we did something like that as we were working through this that caused it to infinite loop. And then it didn't catch the fix when we made it.
So it wasn't the code that was causing it, was the fact that it was updating and the watch was trying to look for it?
Bingo.
So, okay.
I'm getting a weird TypeScript error. Can I share my screen?
Please do.
Can you see?
Yes, I can.
Okay, so this is the error.
It says argument of type string is not assignable to type never. So that would be because your used names on line 8, you didn't tell it what type is going in that array. So you need to set used names to be of type string. Sorry, an array of strings. So that's value level code there. It needs to be on the other side of it. So you need to annotate used names.
So up here?
Nope, on line 8.
Oh, okay. Oh.
There you go. And so that's going to be an array of strings. String is singular in the type. There you go.
Okay, thank you.
No error. All right, other questions about what happened here before we move on?
So where was it that we were able to define the property new name? I'm getting the property new name does not exist on type robot.
So new name is just internal to this method here. It shouldn't exist anywhere else.
All right.
And note that it's not this dot new name or something. It's not part of the actual object. It's just a regular old procedural variable that's only in this method here.
Oh, I see. All right, excellent. So
in object-oriented language, that's called a local variable. So a property is part of the actual object. We can also just make regular old variables that live inside of these scopes and then die when they're over. Those are called local variables.
My npm test still isn't doing anything.
Then you probably have an infinite loop somewhere.
Yeah, I'm getting infinite loop also.
So, Make sure that's still working. Does it work when I put the other tests back in?
See, I'm wondering if once we made that change, if it caused another one to start to fail.
Maybe. Kill all and start over again. Okay, so if I run all of those. Okay, those are clean. Will it do it continuously? Yeah, looking all right so far. And I wonder if it'll let me do the rest of them now. Let me take out my onlys. Oops, still one more. Oh, this might be part of your problem. I don't think this is actually infinite looping. It is checking every single permutation of numbers and strings to make sure that it can generate all bajillion combinations of this without getting a repeat.
So it's just processing over and over and over.
Yeah, it might be.
It's not an infinite loop. It's just a massive loop.
Correct. It could be. So like, yeah, that's the number. So total number of names is. Oops! Stop it.
Is there like a dot filter or something that I mean, like if you find it, then, or it has to be this do while stuff?
Well, I mean,
should we go through?
We could do it recursively. That would probably be even worse on your computer. There you go. That's how many like things it has to check against.
Oh, well, you're not sharing.
Oh, sorry.
Julie, I also thought we were going to do like a dot find.
Yeah, I thought, look, it's there.
Yeah, but then how do you make it go again?
That's the problem I ran into. I was like, okay, now what?
So that's how many different combinations it's checking against. So it's like it's resetting your object that many times to see that it didn't get a repeat.
So it hasn't happened yet, but if smoke starts coming out of this thing, what the hell do we do?
You can kill all node. But look, it's gotten it was up to 6 tests earlier, and now it's up to 9, and there's only one more. And the last one is the killer one. Every name can be generated. So yeah, like.
So do we just assume we're good then?
Probably so. I don't have a shitty computer, and it's taking this long. So let's see. Let's see if it can figure it out. Although I'm also running OBS.
You're gonna have to do this for all of our submissions.
What was that?
And you're gonna have to check all of our submissions, right?
Oh yeah.
Thanks for assigning the to us plural site.
Yeah, for looping. What was it? 500,000 times. That's a pretty damn big loop. So I think that's probably it. Wait, I'm going to keep letting that run, and I'll let you know. Let's take a look at the code again, though. Other questions about... No. Any other questions about this code? Especially the static stuff. Remember, a single robot should not be keeping track of every name that every other robot has ever used. That is a classic case of something that the class itself should be doing. That's what static stuff gets used for. Oh, you know what? I'll bet it's this release names thing. Yeah, that might be it. So release names is this thing here. That's supposed to clear out your use names. Now, if you're like, brain doesn't hurt enough already, in a static method, This refers to the class, not an instance. So you should be able to do use names equals whatever. All right. Well, let me stop it. Let me stop it. So that's a sign that it wasn't an infinite loop. But I wonder if having the release names fixes that. All right, I got 9 in 5 seconds. I
While
wonder.
we're waiting, can you show your screen again of
Totally.
the code which you changed to return? Is it this username? Okay,
I guess
with an array.
I guess I don't need to return it either.
Okay.
But yeah, release names just resets that array. And this refers to the class, not an instance, because I'm in a static method already.
Do you need a semicolon after it?
Nope, they're not required.
Oh yeah, I forgot. Automatic.
Just a style thing. Yeah, it's that automatic semicolon insertion.
Does code, like when we're doing real projects,
yeah,
usually take a long time to compile?
I mean, it is if you're iterating 500,000 times through something, but no, I wouldn't say that's like a... and also, OOP code is slow as shit to compile, like, as a rule. But no, this is because that test is, like, really trying to put the screws to you to make sure you didn't find some janky way to get the test to pass. Also, it could be that includes is just super slow. So here's a good example of trying to change an implementation to something that's more efficient without necessarily changing anything about the public interface. Because remember, the public interface is still just this. It's got a name and it resets. Everything else I should be able to change anything I want to about without breaking any of the tests that are already working. So maybe a more efficient way to do this thing, so it's not trying to iterate 500,000 times and call includes each time, is to use a set. So set's is a type of object in JavaScript. It's a math thing. Works a lot like an array, except if you try to push 3 into it, it just doesn't do anything. If you try to pass 5 into it, no problem. If you try to pass 5 again, you get the exact same thing back. It's guaranteed uniqueness. So maybe what we do is we say use names is a new set. This, I assume, takes a generic of string. But I guess we'll find out in a sec. I did not get a type error there. I'm just going to kill that. And so then this would be the same thing. Set might have a clear method. Let's check. All right, so what methods are available? Clear. So this does have a clear method. We'll just use that. So this would be this.usenames.clear. And then instead of pushing into unames, I think it's add. Yeah. And then instead of includes, it's has. All right, so that's all we changed on this. We changed that from an array to a set, which is kind of like a special array. Whenever we reset it, we call clear, which takes everything out of the set. Whenever we find a new one, we add instead of push. Instead of using includes, we use has. I wonder if I can handle that. Moment of truth. 9 tests. Come on, baby. Is set more efficient than array? Should be. Well, I'll let that crank for a sec. Any more questions about object-oriented stuff, classes, methods, properties, static stuff, interfaces? Going once, going twice.
What do we use for replacing the includes in our do while loop? I'm sorry. Has.
Has.
Great, thank
that's
you.
the set method for that. And add
Has
is the one
and
to
add.
add it.
So we use add because it's no longer an array, right?
Bingo. Push is an array method. Add is a set method.
Oh, Chris said he got a pass.
That's exciting.
Yeah, I'm thinking I can
Took
put
me
the
a
winner on
whopping
my laptop now.
32.262 seconds.
There we go.
Can you scroll all the way to the bottom of your code again? I missed the robot.
Oh, like that was just for playing around. We don't need it.
Oh. My code just saves me then.
But yeah, slow as shit, but it did manage to check through 500,000 things in like a minute. That's pretty good. We couldn't do that in the 60s.
See, I still get one failing too.
I know it's been said before, but it's really, really helpful to visualize the take it one test at a time in these sessions, and it's really, really helpful to get started, because otherwise you see all these things and you're like,
too much.
Dude, where the hell do I even begin?
Yeah.
So just one test at a time, and you really can just make it work.
At a time. Yes.
I got 10 tests to pass in 50 seconds.
Woo! So I wonder, actually, like, I'll bet it's a constant time versus a linear time thing. Performance difference between array includes and set has. Okay, so push is faster than add. Arrays iterate faster. With small arrays or small collections, set was faster. With big ones, the array was faster. Okay, locating an index is what we would really care about. Yeah, there you go. Look at it. That's how fast an array can figure out how to find something versus a set. That's like 5 times faster.
Is that just by design?
That's,
because of how they'll search through?
That's the point of a set. Since sets are guaranteed to be unique, and since order is not guaranteed in a set, it can do things like internally sort them, and it's way easier to find things in sorted information than it is in unsorted information, versus arrays, which it can't really sort internally because like arrays do have meaningful order to them, but sets don't. So it can make different trade-offs when it's figuring out how to find something with a set than it can with an array. Because it can go, oh, I'm trying to find, like, for example, if I have like 1, 5, 10, 20, these are the items in my collection. If these are in a set, they don't have any guaranteed order. So that means internally, it can sequence them this way, even if I added them in backwards order, even if I added them 20, 10, 5, 1. If I do that with an array, it can't resort them for me because the order that things are in an array matters. So it's not going to reorder those for me. But if every time I add something, I can do it this way, and I go, all right, I'm looking for the number 20. It can do something like, all right, I'm going to check in the middle. All right, that's 10. Well, it's more than that, so I don't even need to check any of this. So then I can look in this direction, and I can find that faster. If I'm looking for 1 in here, I have to do it in order. So I always have to check every single one of those until I find it. If the data is sorted internally, it's way faster to find something. That's why it's faster.
All right, Kyle, I have a question for you.
Beautiful.
As it feels like we're approaching the tail end of the OOP party.
You are correct.
I really just would like a high level on decorators. That's like the one thing that stood out in the vocab. I looked it up and I tried to follow along with what I found on the TypeScript site, and it just wasn't really too clear.
I would not. Okay, so decorators for us are kind of like generics are. Generics are complicated and powerful, and they're one of the things that make type systems so cool, and you absolutely don't need to know anything about how to use them right now other than this. So decorators kind of work similarly. What a decorator does is, if this is a class, a decorator wraps it in another class that has something else on it. And so if this had these 3 methods, we can use a decorator, and now it also has this extra one. Just a second. So like, that's all a decorator is for, is adding properties and methods to classes. It decorates them with those. And so the syntax for that is going to be like at some decorator, and then you invoke it. And what's cool about them is that they're configurable. So if this thing could be that, or that, or that, you can pass that into the decorator just like you would a function. Works the same way. And so like in TypeScript, or in Angular, these are like usually objects or something with like the template and whatever else, all those URLs. Angular is using that to add a bunch of hidden classes or properties and methods to the class so that you don't have to write them out yourself. It's kind of like inheritance, except way more powerful. And then we can also do that. There's also decorators for properties that like supercharge that property with new functionality. So in Angular, we do things like that makes it so that you can pass something into that through a template. Or if you want something to be able to emit an event, you can do that. And really, that's about as much about decorators as you need to know. You don't need to know how to make your own. You don't really need to like wrap your head around the mechanics of how they do any of that stuff. It's totally fine to just memorize the syntax and move on with your life.
Thank you.
Very welcome. Anything else?
Not related to this particular assignment, but on the assignments that we have for our JavaScript class questions, the very last one that's in there, do you think if it's not today, do you think that's something that as a group we could walk that one? Because I'm very confused by it.
Well, let's see
if we can at least break through the language on it.
So JavaScript classes?
Yeah, the questions.
Write the code to instantiate. This is what, okay, so lots of people have gotten this wrong. You don't need to make the class. Just assume the class already exists. How do you instantiate a class?
The new keyword.
The new keyword.
With the new keyword.
Right. So you're going to use the new keyword to make an object with the class assignment. You can just assume that it's already been defined somewhere. And you need to pass it 2 different values. And then you need to take the object that you made with that class and call it a public grade method. What most people have been getting wrong on this is they try to define the class.
Gotcha.
Just instantiate it.
Okay.
Anything else? Hopefully we feel a little bit more confident with OO. The fuzzy picture is 10% clearer. It's not the last time we're going to talk about this. And especially when we get into Java, Java is just more of all of this shit. Yeah, there you go. I'm going to try to keep an eye on the submissions through the end of the day. So as you're working on stuff, I'm going to try to kind of be on top of that. So elsewise, hope that helped. Go learn something.